Hello student, welcome all of you. This is a lecture for the B.Sc. second year student and our paper is group theory 7th paper. Semester is 3rd and our chapter is 2nd. Today's date is 5 November 2020. So composition table for finite set. So student, this is a very important concept. Very important. And very interesting. What is that? Composition table for a finite set. We already discussed what is meant by the group, its examples. So if any finite set is given, and if we have to determine whether the given set is a group or not, then we can define it by composition table. If we use the composition table, then it is very easy to identify whether the given set is a group or not group. So binary composition in a finite set can be shown in a tabular form, and that means binary composition, which composition we are using in the tabular form, and that is nothing but the composition table. We discuss it with example. Suppose one set is given and that set is G is equal to 1 minus 1 I minus I. G is a set with 4 elements. 1 minus 1 I minus 1. Actually, what is this? This is nothing but the fourth root of unity. This is nothing but fourth root of unity. Now we check whether it is a form the group with respect to multiplication. With respect to multiplication. So our binary operation is multiplication, and with that binary operation multiplication, I write just here dot. This represent the multiplication. Then draw these two lines. Take these all elements in first row, and in first column we also write all other elements, these elements, and then take product. 1 into 1, that is 1, 1 into minus 1, minus 1, 1 into I, 1 into minus I, minus I, minus 1 into 1, minus 1, minus 1 into minus 1, plus 1, minus 1 into I, minus I, minus 1 into minus I, plus I. Then I into 1, so we get I into minus 1, minus I into I square, and I square is minus 1. Then I into minus I, then I square is minus 1 and minus 1 plus 1. Then minus I into 1, minus I into minus 1, I, minus I into I, 1, and minus I into minus I, that is minus 1. So student, this table is called composition table. And from this table we can identify whether the given set is a group or not group. Here we can observe with this binary operation multiplication, all element 1 minus 1 I minus I, 1 minus 1 I minus I. Their product is again in G. That's any two elements any two elements of the group Z and their multiplication again belong to Z. That means closure property satisfied. If we check the associativity, no doubt associativity will be satisfied. Then we will discuss about what is the inverse and what is identity element. So here we observe that 1 into any element is that element. So therefore 1 is identity element. 1 into any element is that element. So 1 play as an important role as an identity element in this group Z. That means this set Z. So 1 is identity element, first class, no doubt. All three properties satisfied. Next we discuss about the inverse element. So where is the identity element? Where is identity element in that row and column? See here 1, this first row and this first column. So this 1 and this 1 is inverse of itself. Then there is a 1. So this minus 1 and this minus 1, that means minus 1 is itself inverse. Then I, and where is 1? This is 1. I and minus I. So I and minus I, these are inverse to each other. Minus I and I inverse to each other. Minus 1 and 1 inverse each other. And 1 and 1 inverse of itself. So here we found that inverse of every element is exist. So all four properties satisfied. And therefore this set G is group. And it is very easy how to find whether the given set is a group or not. We can find by using the composition table. And this composition table is depend on which binary multiplication is given with respect to that group is an important. So this group is called composition table, but one restriction is there, and what is that? Set must be finite. For the infinite set, it is fail. So, student, you try, you make one composition table for the set G is equal to 1 omega omega square. Omega is an imaginary cube root. Imaginary cube root of unity. Imaginary cube root of unity is a group with respect to multiplication. Is a group with respect to multiplication. So this is homework. G is equal to 1 omega and omega square. This is a group where omega is in the imaginary cube root of unity. And check. Actually it is no doubt. It form group. But I have to go by using composition table. So every student try this example, solve it and upload on our WhatsApp group. WhatsApp group already prepared by our library. So you give solution of this problem or make composition table of this problem and send this on our WhatsApp group. I am waiting for your response. Thank you very much. In next lecture we will discuss some more problem. Thank you very much.